Winter limnology refers to the period of time that ice cover is present on the surface of a lake. Besides the incredible beauty that accompanies a lake with ice cover, winter limnology is important for many reasons. When studying a particular lake, it is important to monitor the water quality year-round, even during the winter when primary productivity is low. Monitoring during winter does not need to be done as frequently as the warmer months, but the lake manager will generally want water quality data at least once a month during ice cover. When a lake manager begins a new project on a lake, they will often review any past water quality data that has been recorded. In an ideal situation, this data will be continuous, meaning there will not be any gaps during the winter months. While it is important to monitor water quality during winter months so this data is available, there are certain trends that a lake manager looks for, with the two biggest being temperature and dissolved oxygen. The arrival of ice cover on a lake changes the characteristics of the water below. These include lake mixing, light penetration, biology, and even the chemistry of the water. Under normal, ice-free conditions during the summer, water near the surface gets heated by the sun and floats on top of the cooler, denser water below, resulting in the standard stratification pattern that is observed. However, during the winter months, an inverse stratification is observed due to a unique property of water that results in maximum density at 4 degrees. As air temperatures decrease during winter months, the surface water begins to cool to 0 degrees, and when wind mixing is reduced enough, ice forms on the lake. The water just below the surface of the ice will be close to 0 degrees, resting on top of the denser water below that will be close to 4 degrees. This stratification period is not nearly as stable as summer stratification. Dissolved oxygen concentrations under ice cover are important to monitor throughout the winter. Ice cover prevents any contact between the water and atmosphere, which means the lake won't be recharged with atmospheric oxygen until the ice melts away. Ice and snow cover also reduce the amount of light penetration below the surface, reducing any photosynthesis and related oxygen production. Fish and other wildlife, including bottom-dwelling bacteria that decompose organic matter, use up the oxygen that is available. During prolonged winters, and especially in productive lakes, it is possible for oxygen levels to be reduced enough to create anoxic conditions. Winter anoxia can result in massive fish kills. Research in winter limnology has been scarce compared to the amount of research that has been done during the more productive growing season. There are a number of research topics during the winter season that require attention, including information on the composition of phyto and zooplankton communities under ice and how these compare to compositions during the growing season. Productivity during the winter season varies greatly across lakes, from barely any production to vibrant plankton communities. The amount of snow cover and type of ice can play a big role in determining the amount of productivity below. Black ice is more transparent and allows for light to penetrate deeper into the water column than does the more slushy and white snow ice. Sunlight powers photosynthesis in the phytoplankton community, resulting in more productivity under black ice. While winter limnology is very important, safety is always the #1 concern, and the thickness of the ice dictates what can be done on the lake. As a general rule of thumb, if the ice is 2 inches or less, stay off. If the ice is 4 inches, it is good for a walking individual. 6 inches is good for a snowmobile or ATV. 8 to 12 inches is good for a car or small pickup truck. If you are unsure of the current ice thickness, contact a local bait shop or lakeside resident to ask about conditions. Once you've arrived, check the thickness with an ice auger and/or ice chisel. It is always a good idea to come prepared with a safety kit, including an ice chisel to check the thickness of the ice as you move across, ice picks or screwdrivers that you can use to pull yourself back onto the ice with, and warm, buoyant, waterproof clothing. If you happen to fall in, it is important to know what to do. First of all, do not panic. Turn towards the direction that you came. Pull yourself back up on the last piece of ice that you stepped on, using ice picks to help in pulling yourself up while kicking up with your feet. And once you're lying back on the ice, roll or pull yourself away from the weak spot before trying to stand up.